So now that we have most of the motion component kind of laid out, we need to go ahead and handle the replication part. So basically telling it to start and stop, as well as the actual implementation here inside of tick. Now it's going to be pretty straightforward to do. All we're going to do is just have a replicated bool define the state. So uProperty, we'll do replicated using, and we'll make a new function called onRep underscore is, I guess, is running. Then bool b is running, and it'll be false by default. So now we can have a u function, void onRep is running, and that'll be done. Well, take care of that. So what we want to do in start motion is basically just do the replication side of things, which really all that is going to be changing b is running to true if it's not already true, and calling the onRep. So we also need to implement the get lifetime replicated props so we can mark is running as a replicated variable. So let's go ahead and create the definition for get lifetime replicated props and include net Unreal Network and net core push model.h. So we want f do rep lifetime params. We'll just call it params. We're going to set params dot b as push based to be equal or to equal true, and do rep lifetime with params fast u motion component. Then the variable, which is b is running, and then pass in the params we defined right here. So we have b is running and it is push based. So next up, we want to change it only server side. So on the motion component, what we want to do is create basically a has authority function, just like actors have, so that way we can use it in a consistent manner. So basically, all we're going to do is bool has authority, and it's going to return get owner role equals role authority, like so. So if the owner of this component's role is role authority, we have authority. Otherwise, well, we don't. So now we can just do if has authority, then we can make the changes. So if we have authority and b is running is false, we can set b is running to true because we only want to change it and mark it as dirty if it has changed. And then we can mark property dirty from name. So the class name being u motion component, the property being b is running, and the class, or the object rather, being this. In which case, we simply call onRep is running. So that way this fires on the server as well. So in onRep is running, we're going to do basically just setting the tick. So set component tick enabled. So basically, if b is running, we set tick to true. If it is not running, it is set to false. And that's pretty much it. So now the only thing we need to do is implement the actual logic to move. In our case, we're just going to move the owner, which is going to, what's the word? Because we're just doing the owner, it's going to basically take it from here to 0, which is, here. But it'll be enough to make sure it actually works for the time being until we implement the part where we actually gather the information about which component we want to move. So what we want to do is if the location curve is valid, we want to basically iterate through that curve. If the rotation curve is valid, we want to do that, so on and so forth. So to begin, we are going to first off need a way to kind of accumulate a value to walk the curve. So as you can see, we have location curve. We can get vector value, and the parameter it takes in is the time in the curve at which we want to access the value. Also make sure to include curves curve vector.h. So we need to basically create that time. So we're going to create a new variable, We'll just call it float curve time and just set it to 0 by default. Then at the top of tick, we're going to do curve time plus equals delta time. That's the only thing we're incrementing it by. So the target value is going to be the vector curve value at curve time. So const f vector target vector equals location curve get vector value, in which case we can then interpolate to that target. So, or sorry, not interpolate to the target, move to the target instead, I mean. So all we're going to do is just, well, move the owner. So get world, or sorry, not get world, get owner, set actor location to the target vector. So let's go ahead, close down the editor, recompile and relaunch, and get our curve set up. And it's probably not a bad idea to go ahead and print out a log with the curve time so we can kind of get an idea on, how long do we want it to be? So like how fast does the curve time, well, increment? Okay, so we are missing some stuff. Oh, that's right, because interact. So we need to call start motion on the motion component inside the barricades interact function. We never ended up calling that. So now let's go ahead and give it a try. Okay, so we're having some additional complaints regarding the push model specifically. So inside of the core module, let's go ahead and open up the build.cs. And under gameplay tags, let's go ahead and add net core. And that contains the push model stuff that it needs. So let's recompile and relaunch, and hopefully now we are good to go. Okay, once we are back in the editor, we can go back to our data asset and we have our various curves. So let's go ahead and make a test curve. So miscellaneous curve, curve vector, and this will just be a test or temp location curve. And we'll set that as the location curve. We can open that on up, and we want to get a value for, in our case, X. So we want a keyframe on X, like so, and now we can just move, Y and Z back to 0. We just, wanted it to be, able to access X basically. So at the length of 10, we want to have, let's see, how far do we want it to move? So it's not going to be correct, but do it in steps of 50. So 5, 10, 15, 20. So a value of 250. And let's do a normalized view. And we can go ahead and save. Or better yet, let's just close and reopen. So it has a, you can actually see everything in frame. So pretty much this will linearly on the x-axis move, 250 units to the right. However, in our case, it is going to move toward origin and offset a little bit just due to it being in world space currently, as we are moving just the owner. So let's give this a try. Walk up to it, press F. And as you can see, it went right over there as it starts to interpolate across. And we can see the curve time as well. So 10 seconds, a little on the long side. So we're going to want to shorten that up, but let's go ahead and get the remainder of the logic in to actually use a specific component, to move. So while we have these properties here, we want an additional one. So it's going to be a f name. We can either do this in, one of two ways. We can either do it by component, which would be, in our case, the static mesh component, or by component tag. So if I view, I don't know if I even have any actual blueprints, do I? Yeah, we do. So if I select, let's say, the mesh component from the character and search for tag, we can give it a component tag. So that's another route we can go. I'm going to do, let's see, I'll do component tags for now, because this can be easily changed in the future. So that way we just have a default tag defined in the motion component to look for. So let's see, what do we want the tag to be? Let me actually think of a tag on that really quick. All right, so I decided on the name motion component, motion controlled component. So we're going to create a static f name. We'll call it motion controlled component tag and set that equal to motion controlled component. So this is the tag we're going to look for. So inside of barricade.h, .cpp, where we create the static mesh, what we can do is we can give it that tag. So static mesh component, we can search for tags. We should have component tags, and we want to add the tag of motion controlled component, which would be basically just found here because this corresponds to motion controlled component. So now, either inside of set motion data and or begin play, what we can do is simply, actually that's probably not a bad idea. We can probably get away with just begin play. Let's see. No, because that might fire too early when the component has not been created. So we're going to do it in two places, begin play as well as set motion data, in case we can't find it here. So go to get owner, get component, or get components rather, by tag, and it's going to take in a component class. So in our case, we want anything derived from uScene component. So uScene component, static class, and then the actual tag, which was the motion controlled component tag. And then this returns an array uActor component. So found components. It actually just occurred to me to use not get component or get components, but find component by tag, because this will return a single component instead of an array. So we just want one single found component, and this also has a template version of it, so we can cast it to a uScene component, which means we don't need to add the scene component class as basically the type. So now we just want to store this component, and I can actually get rid of that. So we want a t object pointer of a uScene component, and this will be the component to move. And we want to wrap this as a u property. So component to move equals the found component here. So let's go ahead and copy that and paste it down inside of set motion data. So that way we can hopefully find it, regardless. So let's close out of this, recompile, relaunch, and actually, before we relaunch, we need to actually move this component instead. All right, so instead of basically modifying the owner, we use the found component. So in case that component, is not found, we don't want to access it and cause a crash. So if component to move is valid, then we can go ahead and run the remainder of the logic. So component to move, set relative location, and that's going to be the target vector. So let's go ahead, recompile, relaunch, and just see if we are good to go. All right, back in the editor, everything should be good to go. Let's click this. We might even be able to find the tag, which it has the component tag of. And yeah, make sure it didn't duplicate, so we are good to go. So we can go ahead and give that a try. Press F, and there it goes, just to the wrong direction. So I had forgotten that we are in relative space. So if we change the gizmo to relative, we can see that the x-axis is actually this direction and not, the other way. So basically, we want to swap out the x for the y and make the y negative. So here we have the y. Let's add another key. And let's see, we're using the value of 250. So we're going to do negative 250 like so. And then we can remove the key from the x and set these back to starting at 0. So let's set the, we also need to shorten it. So instead of doing, say, 10, let's try 2.5. So now press F. There's our door. So I think that's going at a decent enough speed. So let's change the curve length to 2.5 just to match the, well, the length of the curve here. And what we want to do is stop ticking. So for example, if I press F, you can see we are constantly accumulating. We are at 2.5 and we go beyond. It's basically infinitely, accumulating. So even though the door itself is right here, we're just wasting resources. So once the curve time goes beyond, well, what do you call it? The curve length, we want to go ahead and just stop ticking. So if curve time is greater than curve length, we want to set component tick enabled to false. So we just flat out stop ticking. So now that we have that, let's go ahead and make sure that that works. And that'll be it for this video. So that way in the next one, we can do the rotation as well. So press F, starts to go through, and it is still ticking. So let's see. We have curve length set to 2.5. Curve time is definitely greater than 2.5. So let's see, what is the length? So we're going to print out curve length. Open it up, and length is still 10. So this is where that refreshing issue is coming into play. So basically, we're setting the motion data, but the problem is we're only setting it when the bundle is loaded, which is when on construction runs. So anytime I move it. So if I move it and then press F, now as you can see, it is 2.5 and it stops ticking like so. It's no longer printing. So what we want to do is set the motion data in begin play like that. And I guess technically we can also just do it, in both places. It really doesn't matter in case we need to see the actual information, but this should resolve that problem. So let's run live coding. And we will change it to, we'll do 4. So now we should see the value of 4. So whenever we set it back to 2.5, as you can see, we are good to go. It actually updates, how we want. So we're just doing it in begin play as well as in on bundles loaded, just in case it's, necessary. All right. So that is going to be the remainder of this video. It's going on a little bit long. And in the next one, we're going to go ahead and implement the rotation portion of things and get that, this component basically set up to where we are good to go and we can apply it to anything we need. So I'll see you in the next one. If you like what I'm doing and you want to help support me, you can find a link to my Patreon in the description below, where you can also get early access to this entire series.